Okay, so this is section 6.2. We're going to have a quiz on 6.1 and 6.2 on Friday. So we're not moving on to 6.3 tomorrow. We're going to stick with the first two sections of chapter 6 and have a quiz on Friday. First thing to do, I made a typo. Go ahead and scratch out that top fact and that little statement. Just go ahead and scratch that out. That's a typo, okay? And let's begin this section, 6.2. It's titled Inverse Functions. So 6.1 was all about functions. It was about evaluating functions. Like if I told you find f of 5, you plug in 5, get the answer. Or it might be even adding, subtracting, multiplying, dividing functions like f of x plus g of x, or f of x times g of x, or f of x divided by g of x. We were dealing with a lot of functions on the first section. Right here we're dealing with a specific type of function. It's an inverse function, okay? So if you read it from the book, page 393, it reads exactly like this. The inverse relation is a set of ordered pairs obtained by exchanging the coordinates of each ordered pair. The domain of a relation becomes a range of its inverse, and the range of a relation becomes a domain of its inverse. What the heck does that mean? It simply means this. To find the inverse, switch the x and the y values of each coordinate. Okay? So, can we find the inverse of those coordinates? What is the inverse of those coordinates? What's the inverse of 5, 1? 1, 5. What's the inverse of 2, 6? 6, 2. What's the inverse of 5, 7? 7, 5. Do you get it? That's how we find the inverse. Okay, we're done. I'm just kidding. But that is the beginning fact, right? I mean, to find the inverse of any graph, you could take the coordinates and just switch the x and the y. Okay, so don't forget that. Then I have a couple of other exercises, steps that I want you to go through so you could realize certain truths. Number one, they want you to plot both relation A, which are the coordinates 5, 1, 2, 6, and 5, 7. Let's actually plot those. Let's plot 5, 1 on this graph. 5, 1 is right here. Everybody put a dot right there, please. If you have different colored pens, right now is a good time to use them. Let's plot 2, 6. 2 on the x, 6 on the y. That's right here. And let's plot that last one, 5, 7. So 5 on the x, 7 on the y. It is up here. Okay, so now let's plot the inverse of those coordinates in red. So 1, 5 is right here. 6, 2. 6, 2 is right there. And 7, 5 is right there. Now there is something going on with a coordinate and its inverse. Does anybody see it yet by any chance? Rotating? How about this? Let's move on to the next instruction or step exercise I want you to do, and we'll be able to see it then, I'm pretty sure. Let's do step 2 and 3, or exercise 2 and 3. Number 2, I want you to plot the triangle that has the coordinates -7, -5, -7, 0, and -3, 0. So let me do this with some green dots. -7 on the x, -5 on the y. Now let's go -7, 0, and let's go -3, 0. And we might as well draw this this green triangle. Got it? Okay, now let's graph. The next step says plot the inverse of that triangle. So what are we going to do? How do I graph the inverse of this triangle? Switch the coordinates. So what's the first coordinate I'm going to graph? Instead of -7, -5, what am I going to graph?
-5, -7.
Perfect. There it is. -5, -7. You go -5 on the x, -7 on the y. How about this next one, -7, 0? I need to switch it, and it becomes 0, -7. 0, -7 is down here. And then this last one, I need to switch it. It becomes 0, -3, which is right here. So what do we have here? We have this red triangle. Does anybody notice what visually happens when you graph something and then you graph? Wow. And then you graph the inverse. Oh, great. Anybody? What happens when you graph something and then you graph the inverse? It reflects. It doesn't rotate, it reflects. Does it reflect over the x-axis? No. Does it reflect over the y-axis? No. So where the heck is it reflecting? On what line? What line is it reflecting on? Got to think Algebra 1 to say that the line. You guys see this line right here?
Rise over run.
Yeah, rise over run. What would the rise over run be on this line right here? Because you could clearly see it. This green x equals y equals x, right? So this green triangle clearly reflects over this line and it gets reflected over here. This red dot gets reflected over here. This blue dot gets reflected over there, and so on and so on. So when you graph something and then you graph the inverse of that something, it really does get reflected over the y equals x line. The y equals x line. I mean, after all, when I tell you find the inverse of something, what are we doing? We're switching x and y. Now, the only logical way that you could just magically switch x and y is if x equals y, right? So that's why it ends up being like a reflection over that y equals x line. Anyway, that's how to find the inverse of any set of coordinates. We also need to know how to find the inverse of any given function f of x. So before talking about how to find the inverse of f of x, of any given function f of x, we need to talk about inverse notation. This notation, it's really not f to the negative 1 power. That's not it at all. This is the notation that really just says it's the inverse of f of x. Okay? So this right here, g to the negative 1 power parenthesis x, that really just reads the inverse of g of x. Make sense? So whenever you see this power of negative 1, it's not even a power. It's just the notation saying that they want you to find the inverse of whatever function they're talking about. Okay? Now, how do we actually find that inverse? It says right here, to find the inverse of a function f of x, or using the appropriate notation, to find the inverse of f of x, you switch x and y, just magically switch them, and then you solve for y. Okay, again, how do you find the inverse? You switch x and y, and then you solve for y. This is the important part of today's lesson. How do you find the inverse? You switch x and y, and then solve for y. Switch x and y, and then solve for y. So let's take a look at number 1, and I hope we understand the notation. Right here, when they say find this, that's really saying find the inverse of f of x. Okay, so what is the inverse of f of x? Well, how do you find the inverse of f of x? Here's f of x. How do you find the inverse? Switch x and y. Okay, well, I see an x right here. Where's the y? F of x is really y, right? So let's first start by writing it with x's and y's. Here's your y, here's 3/5, and there's x. So how do I find the inverse? I switch the x and the y. I switch. Go ahead and copy that down. Switch the x and the y. So magically, what we have, instead of y equals 3/5 x, we're going to have x equals 3/5 y. That's the first part of finding the inverse. You switch x and y. But what's the second part of finding the inverse? Solve for y. That's what it says. You switch x and y, then you solve for y. So y is clearly on the right side of this equal sign. I want to get rid of this fraction. I'm going to have to multiply both sides by 5 to get rid of the 3/5. I'll have 5x equals 3y. So my final step would be to get rid of the 3 by dividing by 3. And there's my answer. Y equals 5/3 x. So that's my inverse. Now, with the appropriate notation, we would say or write it like this. F with that little negative 1 as an exponent, but it's not really an exponent. That's just saying the inverse of f of x is, and you would write the 5/3 x. The inverse of f of x is 5/3 x. What do you think? Well, the dog doesn't like it, but I hope you guys do. Again, how do you find the inverse? Switch x and y and solve for y. Let's find the inverse of the g of x function, right? Here's my g of x function. Let's begin by making it look like x's and y's. Y equals 3x minus 2. Now, how do I find the inverse of this function? Switch the x with the y, Switch. So we're going to have x equals 3 times y minus 2. Again, that x equals 3 times y minus 2. And after you switch it, what do? Yeah, you solve for y by getting rid of that minus 2. So let's do that. Plus 2 here, plus 2 over here. Rewrite it. X plus 2 equals 3y. So what's my final step going to be to get y by itself? Divide by 3, divide by 3. Y equals x plus 2 over 3. There's my inverse function of g of x. So using the appropriate notation, you would say the inverse of g of x equals that answer, x plus 2 over 3. Now, if you're taking a midterm or a final and it's multiple choice and you don't see that exact answer, they might have taken the denominator 3 and split them to each of the terms, to the x and to the 2. So another perfectly acceptable answer would be the inverse of g of x equals 1/3 x plus 2/3. They might split that denominator to each of the terms. Any questions? Yay? Nay? Okay. So let's move on to the next and final portion of today's lesson. We did scratch out that top part. Let's just jump right to the key concept. Key concept says, if you plug in your g of x function into your f of x function and you work out all that math and your answer is just x, and then if you do the opposite, plug in your f of x function into your g of x function and you work out all that math and your answer is just x, then you could safely say that your f of x function and your g of x function are inverses of each other. Okay, so if I asked you, is the f of x function and the g of x function, are they inverse functions of each other? Well, you could make this y, make that x, switch x and y and solve, see if it actually gives you this. And then you switch it again and you do it backwards and see if it gives you that. But the above key concept allows you to plug one into the other and then vice versa. And if both of them equal x, then you know for a fact that they are inverse functions. So let's check that. Let's do f of g of x. What does that mean? I'm going to plug in my g of x into my f of x function. And my answer should be just x. Okay? So I'm going to plug it into my f of x function. My f of x function is 2x minus 8. Now, if this had an f of 5, I would just plug in a 5 right there and do the math. But it's g of x. What is g of x? 1/2 x plus 4. So that 1/2 x plus 4 is going to go right in there, right? The g of x function is really 1/2 x plus 4. Plug in that 1/2 x plus 4. And now do the math. We're going to distribute 2 times half x. What is 2 times half? 1. So you're going to end up with just an x. And then how about 2 times 4? 2 times 4? 8. So you really have x plus 8, but then you have the minus 8 over here. And what happens with that plus 8 and that minus 8? Cancels out. What's your answer? Just x. So far, you got to check right there. You've so far checked this first f of g of x. It really does give you x. You need to check it the other way around to make sure that these are inverse functions of each other. Okay? So since we've already done f of g of x, let's now do g of f of x. G of f of x. So let's plug in our f of x into our g of x function. So our g of x function reads 1/2 parenthesis x plus 4. So instead of the 4, we put parentheses. And we're taking the f of x function and plugging it right in there. So you have a 2x minus 8 right in there. So when we distribute that 1/2, we end up with 1/2 times 2x. That becomes a 1x. Or you could just put regular x. I know, this math sucks. I'm sorry. And then 1/2 times negative 8, that becomes negative 4. And of course, you have the plus 4 over there. And once again, the minus 4 and the plus 4 cancel out. You end up with just x. So this is not an answer. This is just a way to check to say yes, f of x and g of x are inverse functions. So yes, they're inverse functions. Why? Because when you plug one into the other, everything cancels out except for x. And when you do it the other way around, it also, everything cancels out except for x. So we have this in our homework. So we're only doing numbers 1, 3, 7, 9, and then 10 through 15. 1 and 3, man, these are ridiculously easy. They want you to find the inverse of these coordinates. So what's the answer, number 1? 3, 0. 2, 4. Negative 6. Positive 5. Ta-da! Easy peasy. Just switch x and y. You have the inverses of the coordinates. Yay? Yay. This second part of the homework, 7, 8, and 9, you're only supposed to do 7 and 9. I'm going to do number 8 for you. You see, in Algebra 1, we learned about y equals mx plus b. G of x really is y. And instead of 3 plus x, let's write it as x plus 3. Now it really is in y equals mx plus b form. Okay? So it obviously crosses the y-axis. What's the b value? 3. I hope we remember from Algebra 1, right? It crosses at 3. Put a dot right there. And what's my slope? What's the m value in front of the x? Up 1 over 1, right? So if you go up 1 over 1, you end up right there. Up 1 over 1 right there. Using the pattern backwards, you have this line right there. So we have graphed this line, which we could call g of x. Okay? Now they want us to graph the function. We already did it. They want us to also graph the inverse of that function. So how do you do that? Well, you could simply reflect that line over the y equals x line, or you could actually just do one coordinate at a time. This coordinate right here, that's negative 3, 0. If you switch it, it'll be 0, negative 3. This coordinate right here, that's really 0, positive 3. If you switch it, it'll be 3, 0. You can pick any coordinate you want. You could pick this coordinate up here. That's really 2, 1, 2, 3, 4, 5. You could switch it. It'll be 5, 2, which is right there. So when you switch the x's and the y's, you end up with that green line, which really is a perfect reflection over the y equals x line, right? If you were to reflect this line over that, it ends up being this green line. So that green line is the inverse. How could we label it? G with the little negative 1 with the parenthesis x. That's really saying the inverse of g of x. So you guys could do the same for 7 and 9. That's pretty easy. Now the last section where it says determine whether each pair of functions are inverse functions, right, yes or no, that's where you plug one into the other and then plug in the other into the first one to see if both answers give you x. If it gives you anything other than x, then they are not inverse functions. Pick one. Which one would you like to see? 11 looks fun. Why not? Let's do 11. So if I do f of g of x, and if my answer ends up being just x, and then I do g of f of x, and my answer ends up being just x, then I know that these are inverse functions. Okay? So let's plug in the g of x function into the f of x function. Here's my g of x function. It looks pretty ugly. Let's plug it right into the f of x function. So my f of x function reads negative 4x plus 1. Notice I put big parentheses. Why did I put big parentheses? Because I need to plug this in. So I'm going to plug that right in there. The g of x is really 1/4 parenthesis x minus 1. So I have 1/4 parenthesis, I said x minus 1, so 1 minus x, close parenthesis. So let's do this math and let's see if it really does simplify down to x. I'm zooming in right here. So when we look at the inside of the parenthesis, we have 1/4 times 1 minus x. Let's distribute. 1/4 times 1 is 1/4. 1/4 times negative x is negative 1/4 with an x. You guys agree? Okay, let's put the parentheses. Let's put that negative 4 on the outside. Put the plus 1 at the very end. Now let's distribute the minus 4 on the outside times 1/4. Well, negative 4 times 1/4, I know it hurts. That's really negative 1 And when you distribute negative 4 times negative 1/4 x, well, that'll become a positive x, correct? And don't forget about the plus 1 that was on the outside. And now when you combine the minus 1 with the plus 1, they eliminate, and it really does just give you x. Now this is not an answer, it's just a way to verify that they really are inverse functions of each other. Okay, but it has to work for both. If it gave you x right here and over here it gives you like 2x, then they are not inverse functions. So let's do the other way around. Plug in your f into your g. Plug in your f into that g, which is in the parentheses where the x is at. So let me rewrite this whole thing. The g of x function is really 1/4 parenthesis 1 minus, and instead of x, I put some parentheses right there. And what am I going to plug in there? I'm going to plug in the binomial negative 4x plus 1 right in there into the parentheses. Negative 4x plus 1. And now let's do this math and see if it really does simplify all down to just x. So when I take this minus sign and distribute it, it'll become a positive 4x. Distribute it over here, it'll become a negative 1. And then put that 1 out in the front, put the parentheses around the whole thing, put 1/4 out in the front of the parentheses. Inside of the parentheses, I could combine this positive 1 with that negative 1, and they really will cancel out. So what I have left is 1/4 outside of the parentheses and 4x on the inside of the parentheses. So how do I multiply a fraction with a term that's not a fraction? You could make it look like a fraction by putting it over 1, then multiplying the top with the top and the bottom with the bottom. You will end up with 4x over 4, and the 4's really do cancel, giving us just x. So we have verified that in both cases it gives us just x as an answer, which means that yes, f of x and g of x really are inverse functions of each other. Now, of course, sometimes when you plug your g of x into your f of x, on the very first one, you get something like 5x or you get like 4x. You could stop right there. They're not inverses. It has to be just x on both of them. So I'm done. Okay? Make sure you finish up this homework. The answers are on the back so you can check your work.